Hello students, in this module we are going to illustrate the Nelson Aalen estimator using R. It is a one non-parametric approach adopted for survival analysis. In survival analysis, generally it is very difficult to follow all patients during the study period. Sometimes we have to wind up the study, and that time so many patients are there, those are having no informations about death or event of interest. In that scenario, those patients are called as censored observations, specifically the right censor observations. When survival data is having right censor observation, in that scenario Nelson Aalen estimators found suitable for statistical inference. It is a non-parametric approach, since we do not need to graphically display the distributions of time of survival times durations. Nelson Aalen estimators having two pioneer papers are there, one came in 1969 and another one 1972. Independently, Nelson and Aalen in 1970 derived the same estimator in the context of computing risks on animal experiment modeling. Later, by adopting a counting process formulation, Aalen in 1978 extended its use beyond the survival analysis and comparative risk modeling. This paper on Aalen 1970 useful for small data survival analysis as well large data survival analysis, and it is adopted through matrilineal methods. The estimator is nowadays denoted as Nelson Aalen estimator, although other names like the Nelson estimator, the Aalen estimator, the empirical cumulative hazard estimator sometimes also used as well. In this module, we will see the cumulative hazard rate estimation using R. We will see the survival analysis plotting using R. We will see the non-parametric estimation procedure, that is Nelson Aalen estimator, through R. The sample data is on chemotherapeutic trial will be considered to illustrate the Nelson Aalen estimator using R here. Here we are going for Nelson Aalen estimator using R. End of this lab presentation, we will get how to graphically display survival data using R, Nelson Aalen estimator using R, and Nelson Aalen estimator and Kaplan-Meier estimation comparison using R. Let's start. This is the data taken from ovarian cancer study in Munson 1979 article, where a few times given as survival or censoring time of the patients, a few stat giving as censoring status of those patients, is in years considered during the study initiation or study entering of those patients, and resid.ds given the residual disease presence or not, that is given as 1 for no and 2 for yes, and Rx treatment groups given here. Two type of treatment given, and another variable, that is ECOG.ps also considered. ECOG performance status considered as 1 is better. There are reference in Google or other found, you may get the what is the literature about the ECOG. Now again we will construct that our objective to find the therapeutic treatment difference on survival duration of the patients. Now we are going for reading to the data. Here the time is taken as 59 days, 115, 156 days, 421 days, 431 days, 448 days, 464 days, 475 days. Like all patients, duration of follow-up is given into the time variable. Secondly, the status of the patients given as 1 and 0. At the end of the study, what is the last status of the patients given. Now Rx given as 1 or 2, it 1 given as the reference group and 2 is the intervention group considered here. And the age of these patients considered as like 72.33 years, and when the first patient entered, his age was like here 72.33. When he entered in the study, second patient, his age was 74.49 years. Like that, all patients are age assigned to the variable name with age. Now coming to the second, residual status as yes or no is given as residual disease is one of the important factor for survival analysis. So residual disease is given as 1 for present and 2 for no. ECOG.PS also given as 1 and 2. What is the score of those patients? Performance score was given. Now whole variables like time, status, Rx, age, residual DS and ECOG assigned to a database called ovarian through a function data.frame. Now we will work with this database, that is ovarian, with a specific package to get the Nelson Aalen estimator. Now initially we have to download this library called library survival. Into most of the packages are compatible with most of the statistical tool in R for survival analysis are compatible with this library called survival. So we have to download and install this package survival, and after that for Nelson Aalen we are doing Nelson Aalen estimator is a non-parametric estimator which may be used to estimate the cumulative hazard rate function from census survival data. It's useful when we are not aware about the distributions of the survival data. So no distribution assumptions are required to apply the Nelson Aalen estimator. It's used to check the graphically the fit of parametric model, and we will come details on that again. Here initially we are putting that to plot the data how the initial data looks. We are calling the attach ovarian, and after that sub fit and sub, where these two functions we are calling to present the survival functions how looks, and whole things are assigned to as a ovarian.surv. Now we are calling the plot function. Into that we are taking the ovarian.surv and labeling the y-axis as time and x-axis as time and y-axis as survival probability. And if we put this plot ovarian.surv and put x lab equals to time and y lab survival probability and put the enter, we will get the display the R will display the survival graphs. Let's come. Let's come to the second slides. This is the R output. So since earlier slide we had mentioned that time and status follows to Rx till Rx. So Rx is given two type, that is 1 and 2. So for Rx1 and Rx2, two graphs are presented as survival plots. Through x-axis duration of follow-up for each patients are given. Since the maximum observation were observed more than 1200 days, so y-axis since the maximum observation was followed for more than 1200 days, so y-axis showing the maximum value more than 1200 days, and and since and from study initiation this probability started from 1 and it keep on decreasing throughout the study period. But you will see here, since in this graph, to plotting this graph, since we didn't mention the legend for two arms, so this graph is not showing which line showing to which arm. So in addition to this graph, if we put the legend function, then we will get that which arm having better survival in comparison to others. But here you can see that there is a big difference from study initiations. Actually, from around 50 days, more than 50 days, the difference started to occur between these two terms on survival, and again around 600 days difference was quite narrow between these two arms. Again it increased and followed the same pattern at the end of the study. Here in this graph we can see so many crosses are there. These crosses are basically showing the sensor observations observed in particular time period. So we will go for next slide. Now we are going for Nelson Aalen estimator. It's an estimator of the survivalship. With an objective can build the table as follow. We are coming to next slides. But it's better to call the Nelson Aalen estimator through the Cox proportional hazard functions. Specifically, there is not any functions available to directly call the Nelson Aalen estimator in R. So in Cox proportional hazard function, if we put type equals to ln into the inverted comma, then it will give us the Nelson Aalen estimator as a non-parametric estimation approach. So here in this code we are showing that sub fit into Cox page within parentheses, again sub, that function is available in library called survival, and putting time and status of those patient follows to Rx, that what type of treatment given to them, and parenthesis end, and again putting type equals to ln. That whole thing we are assigning to a values called a, and when we are next step, when we are calling a as summary a, and then we will get the result. Let's see how the result showing. This is the our output to give the result. Here the first column showing that time of measured in days of each follow-up of patients, like 59, 115, 156, 268, 329, 353, 365, 431, 464, 475, 563 and 638 days, and corresponding that those follow-up period, number of patient were at risk given by the second column, that is n dot risk. You can see that at end of 59 days patients were at risk were 26, and in that period number of event occurred, that is death occurred for only one patient, and that's why this survival probability comes to 0.96, and standard error corresponding that survival probability gives the with 0.03. We are having lower confidence interval, 95% confidence interval with 0.89, and upper confidence interval with 1.00. For next time, that is 115, number of people were at risk were 25. See, initially it was 26 and one event occurred. So during that period 59 to 115 days, people were at risk were 25, that is 26 minus 1, and again in that period one person died. So again probability of survival reduced from 0.96 to 0.92 with standard error 0.04 and lower confidence interval 0.83 to upper confidence interval 1.00. So this is the curves, and if we plot this value into a curve, then we can get the survival plots using the Nelson Aalen estimator. It's one kind of similar kind of estimation given by the Kaplan-Meier estimator as well, but there is some difference that we will see in next slides. How Kaplan-Meier and Nelson Aalen giving the different estimation. Go to next slide. Now we are calling the plot A to get the survival values. Now output, it will give us the Nelson Aalen estimation with the lower confidence interval and upper confidence interval. See again this y-axis given the probability of survival. It started from 1 and end with 0, but since in this function, since we didn't mention that y labeling and as well as x labeling, where x is given the duration of study or follow up in days, this graph is not showing the x labeling and y labeling. We have seen earlier that how to label x and how to label y, so that kind of thing. Again we can, in addition to that function, we can put that, and here these broad lines, that mid lines giving the estimate of Nelson Aalen estimations, and again the cross value between this plot showing the sensor observation observed during that study, and the upper values of the upper line gives the upper lines give the upper confidence intervals of the Nelson Aalen estimator, and lower value give the lower confidence interval of the Nelson Aalen estimator. And you can see that initially it started from 1 and keep on decrease, and at the after 600 days it's stable nearly 0.5, and it steadily it follow. So after since we didn't get any death or relapse observations after end of after end of 600 days. So the Kaplan the Nelson Aalen estimator curves didn't decrease further. It stand as same from 600 days plus to 1200 days plus, but during that period some patients found censored, so it given as cross values over. So you can see during 800 days before 800 days, 600 days plus to 800 days, before that two patients were censored. 800 days to around 900 days, again two patients censored, and again 1000 days plus till 1200 days, 4 patients censored, and again 1200 days plus another patient was censored. So that's showing this Nelson Aalen estimator graph, as well as this probability of survival changes during the study, also given that this plot. Now we are plotting the same thing with minus log with survival functions that we are already assigned that estimator at A. Now A asterisk surf if we put within, and before that if we put minus log and calling it as hazard of H dot Aalen, so it will give us the hazard functions value obtained from the Nelson Aalen estimator. Again we are putting so after that if we ask to R that put H dot Aalen, will give the hazard rate estimations obtained by the Nelson Aalen estimator. Again if we put Aalen dot est here, we are assigning Aalen dot est as cbind of time, that is what is the value given at a of time, d equals to what is the death or number of event observed in the a, and number of risks, that is n dot risks assigned as n equals to n dot risks, and h dot Aalen we already assigned as minus log a of surf, and s of s1 given as surf of these functions. So it will give us the Nelson Aalen estimated functions, and here we are giving that 5, here we are not giving for all observations. So Nelson Aalen estimator for first 5 time points estimation value we are giving in the next slide by Aalen.est of 1:5. So here you can see for time points 59, 115, 156, 268, 329, number of patients died like 1, 1, 1, 1, 1, and number of patients were at risk were 26, 25, 24, 23 and 22, and corresponding hazard estimations obtained through Nelson Aalen estimator is 0.03, again drop down increase to 0.07, and again increase to 0.11, again it increased to 0.15, and after that it increased to 0.20, and corresponding survival estimates given as probability of survival till 59 days given as 0.96, thereafter 115 days is reduced to 0.92, and for 156 days is come to 0.89, and 268 days is reduced to 0.85, and till 329 days is come down to 0.81. So if you add these h dot Aalen estimate value and estimate value of S1, we will get the total value of 1 for each row. So if we add 0.0368 with 0.9638, we will get a value near to 1. So that pattern maintain over, because those are having died, the probability of hazard rate given by that h dot Aalen and probability of survival given by S1 here. Now we coming to next slide. Now we are using the Kaplan-Meier estimations kit to get the Kaplan-Meier estimates. We give the subfit function, and into that subfit function we are putting surf with time and status, and this thing again we are assigning to as came.est to get the Kaplan-Meier estimations, and again we are merging. See, already we are having the Nelson Aalen estimator assigned as Aalen.est, and again here we are getting the Kaplan-Meier estimator that is assigned at km.est, and these two estimator will plot into a single graph to get the comparative difference of these two estimation. To get the comparative estimation of two different graphs, we are considering that function called merge, and into merge the merge data dot frame we are assigning align estimation and comma data frame came estimations by time. If we plot these functions and get the estimates, comparative estimates value, here for the first 5 time points we are giving 1 to 5 as all of 1 to 5, and whole things assigned to as all will get the estimate value like here. So here the S2 is obtained through the survival Kaplan-Meier estimations, and S1 obtained by the Nelson Aalen estimator, and corresponding Aalen estimator, h dot Aalen estimator, and time and number of patient died and number of patient were at risk are given this plot. So it's very easy to compare the survival estimate observed through Kaplan-Meier and Nelson Aalen estimator, and this that is assigned to all. Now this all we are calling to plot it in the next slide, and the code is like all of time and all of S1 type is equal to S to get the line follow up, and here we are labeling x axis as survival time, the months, and y labeling as survival probability. So based on your duration of study, you may put y into the inverted comma what is the unit of the study, that is days or month or year. So we may change accordingly, and y labeling we may also change accordingly, but it's generic term that survival probability. And points we are putting to discriminate the lines basically for Kaplan-Meier and Nelson Aalen, and these lines are also assigned for S1 and S2, and now we are getting the result. Now before that we have to we are assigning the legend function to get the which curves, which lines showing which estimator, as Nelson Aalen estimator and Kaplan-Meier estimator assign in different type, that's why we are giving a PCH with C1 and 3, and seeing we are assigning this legend should become around 800 days through y-axis, and at the most 0.8 through y-axis. Let's see how the curves looks like. This is the curves, and this is the curves for Nelson Aalen and Kaplan-Meier's. So these cross given curves comes with the Kaplan-Meier estimation, and these circle curves given with the Nelson Aalen estimator, and again the survival time in months that we assign as x lab is given through y x-axis, and survival probability given through y-axis. Here we can see there is a difference to getting the estimations by Nelson Aalen and Kaplan-Meier. However, both of them are not parametric approach. We are getting the Kaplan-Meier estimations through Sharpe functions, and Nelson Aalen estimator through Cox proportional hazard functions, but there is a difference between these two estimator. However, both of them found to follow the same pattern in this graph, and from that we can get the, like earlier statistical inference, we can generate the same inference here, that how the patients followed and how their survival rate dropped in certain period of time, like that. This is the comparative figure to get the Nelson Aalen estimator and Kaplan-Meier estimator comparison, as well as Nelson Aalen estimator. In this module, we have seen the Nelson Aalen estimator procedure using R. The sample data on chemotherapeutic trials is considered to illustrate the distributions. The same Nelson Aalen estimator can be applied in other clinical trial application as well as engineering and sociology applications, where data is having censored, specifically right sensor observation. It is a non-parametric approach we have considered for survival analysis estimation. In this module, we have also seen the hazard rate estimation, how to take the statistical inference from hazard rate estimations. We have seen the cumulative hazard rate building using the statistical package in R. I have also seen the statistical inference on cumulative hazard rate using R.